Hi everyone. So now we are going to cover voltage multipliers. So what are the voltage multipliers? What we have already seen: clipper, clamper, then peak detector. Now what are the voltage multiplier? Let's assume this is your input, which is Vm sin omega t. Now voltage multiplier will give you the output higher than the input voltage, higher than the maximum input voltage. So it could be somewhat kVm, but important thing is this would be DC. Let's assume my input is Vm sin omega t, and in the output I want 2 Vm sin omega t. So will you use voltage multiplier? No, you will use amplifier. We will study about it later on. So here your input is AC and output is also AC, which is amplified. AC input and output is AC also, which is amplified by factor of 2. So here you are not going to use voltage multiplier. What is the scene in voltage amplifier? Input is AC, Vm sin omega t, but the output is DC only, but it is amplified by the factor of K. Are you getting this point? Now K can be anything. So let's assume if K value is 1. So V0 will be equals to Vm. So what this circuit will be called? You have already studied about this. You have applied Vm sin omega t, in the output you are getting Vm. What is that circuit? Peak detector, right? Positive peak detector. Positive peak detector. Now if K is 2, then what will be your output? 2 Vm, right? For Vm sin omega t input, if K is 2, that means your output will be 2 Vm. That is called voltage doubler. Voltage doubler. If it is 3, it will be called voltage tripler. And if it is 4, it will be voltage quadrupler. Voltage quadrupler. Quadrupler की spelling तो आती नहीं है. Let me Google it. Yeah, so this is the spelling, voltage quadrupler. So let's see the voltage doubler circuit. But before watching the circuitry, tell me, how will the voltage doubler circuit look like? You have studied two circuit, clamper and peak detector. Try thinking about the voltage doubler circuit now. Clamper and peak detector you have already studied. Now what if there is an input, I give that input to a positive clamper? What will be my output? This is my input, which is Vm sin omega t only. If I give it to a positive clamper, what will be my output? That will be Vi plus Vm, right? That means Vm plus Vm sin omega t. That will be my output. Now if I give this output to the input of a peak detector, what does peak detector do? Positive peak detector. What does positive peak detector do? It detects the positive peak value. What is the positive peak value of this signal? That is 2 Vm, right? So in the output I am having 2 Vm. So basically what you are going to have, positive clamper and then a peak detector. That's it. Positive clamper, that means voltage is shifted upward. Vm sin omega t is shifted upward. So Vi plus Vm sin omega t. And then you just detect the positive peak, that is 2 Vm. That's how you get the voltage doubler, right? So this is what the circuit look like. Here you see, this is the circuit. So here if you see the first one, what is that? This is positive clamper circuit. And what about this? This is peak detector, right? This is peak detector. Let's call this potential as potential V dash. So what will be your V dash? V dash will be Vi plus Vm. that will be at steady state. This is the steady state. Now why I am writing steady state, I will tell you later on. What will be your VC1? VC1 will be minus Vm, right? Because in the positive peak detector, what will happen? When Vin is equals to minus Vm, this diode will be on. When Vin is equals to minus Vm, then this diode will be on. So if this diode is on, that means the capacitor will charge in this direction. Also by the direction of diode, you can see the capacitor will charge in this direction. So it will charge to like this. So VC1 we are taking from left to right, but capacitor is getting charged from right to left. So your VC1 would be minus Vm, but at steady state. Everything is happening at steady state. And what about V0? V0 will be, since this is V, what is this potential? V in plus Vm, right? V in plus Vm, that means Vm plus Vm sine omega t. Now tell me, when will this diode turn on? This diode will turn on when here the supply is here. At this point the supply is maximum positive voltage. What is the maximum positive voltage of this? That is 2 Vm. So when the supply is maximum positive voltage, this will be on, and the complete voltage will be given to capacitor C. Here the voltage will be 2 Vm, and that complete voltage will be given to the capacitor C. So at capacitor C you will have 2 Vm output. We have already seen the method to solve the peak detector circuit as well and the clamper circuit as well. Any kind of diode circuit you can solve if you know that concept. That first turn on the diode by the supply. If you have turned on the diode by the supply, later on you can move around the circuit. So we will solve many examples like that, and by the end of this lecture you will be very comfortable with this kind of circuit. And not just the standard circuit, if you see any kind of circuit in the examination, you will be able to solve that. But here I am writing steady state. So all these is happening at steady state, not after one cycle. Look, what is your input? Vm sin omega t. So your input is something like this. This is your input, right? And it will keep on going. Now it's not that this time is time t, this time is 2t, and after that it will keep on going. It will keep on going. Now it's not that at time t equals to t, your Vc2 will be Vm and your Vc1 will be minus Vm. That is wrong. What I mean to say is that this is your V in time t, this point is plus Vm and this point is minus Vm. If I am writing that Vc1 at time t equals to t is minus Vm and Vc2 at time t equals to t is 2 Vm. This is wrong, because this is not happening instantaneously. This is happening at steady state. What will happen in this cycle? That I will tell you later on. We will solve a problem where we will see what happens in a particular cycle. Then these kind of cycles are repeated and then we reach the steady state. Are you getting this point? First one cycle will come, then another cycle will come. So capacitor will store some voltage, then more voltage, then more voltage. By that it will reach the steady state. Here there is the simulation. So in one cycle it has reached like something like this. This is the output waveform. That means this is Vc2. This is Vc2. This is Vc2. And this is Vin. So in one cycle this much is charged, then another cycle more charge, more charge. So slowly it has reached up to the steady state. Are you getting this point? So it doesn't happen in one cycle, but in the gate examination till now, till this date, they have never asked what happens in one cycle. They have always asked the steady state value. And even a lot of teachers, a lot of students don't even know that in one cycle it is not reached. It is reached in a lot of cycles. Nearly around 32 cycles it will be reached. Just a rough idea, no one will ask you how much cycle it will take. Just as far as I remember, 32 cycles it takes to reach the steady state. So this reaches the steady state in so much of cycle, not instantaneously. What happens in one cycle we will see, but as a question in the next video, in the assignment we will see. Okay, as a question we will see, we will find the value of Vc1 and Vc2, Vc1 and V0. You can say Vc1 and V0 at time t equals to t. Vc2 I am calling this as only. Okay, Vc2 is V0 only. So we will see that, but in the next video. So Did you understand the point? Here what was happening? Clamp up and peak detected. That's it. But now in this question you could see two circuits, positive clamper and peak detector. But there will be many circuits where you will not be able to see the circuit. So how will you solve those problems? So that we will see now. What I mean to say is that कई सर्किट ऐसे होंगे जहां पे आपको दिखेगा ही नहीं कि यहाँ पॉजिटिव क्लैंपर है, यहाँ पे पीक डिटेक्टर है, यहाँ पे दिख गया साफ साफ. But कई there will be many structure where the diode and capacitor will be replaced something like that, that you will not be able to recognize whether it is a positive clamper or peak detector or whatever it is. That will be a simple circuit that you need to solve. So that we will see how to solve those circuit. So how to solve the voltage multipliers. So this is just the statement, just read it and then we will see in the question. So what you need to do, first you need to turn on the diode. The same method is there, but here there will be two, three, four diodes. There can be 5 diodes as well. So there will be multiple diode and multiple capacitor. Till now we have seen only one diode, one capacitor, but now we will see multiple diode and multiple capacitor. So what you need to do, you need to turn on the capacitor nearest to the supply, then you find the, first you need to turn on the diode nearest to the supply. First you will turn on the diode, then you find the capacitor voltage. Based on that capacitor voltage, you turn on the next diode and find the next capacitor voltage. That's it. That's how you need to move. In this question, what I would have done, first I would turn on this diode. This would have turned on at minus Vm. So then it would have turned on. Then based on this voltage, it would have turned on at minus Vm. Something like this. At this voltage, it would have turned on. So now based on this voltage, I would turn on this diode. So here I would find the value of voltage. That would be V in plus Vm. Now to turn on this diode, I need to apply the maximum input voltage here. And that should be 2 Vm. So at 2 Vm, this diode will turn on and your output voltage would be 2 Vm. The diode can turn on at Vn equals to 0 as well, but we will take maximum supply. What is the maximum supply? That is Vm. Maximum positive supply. If this was the scene, we would have taken the maximum negative supply. Right? We have seen this kind of question. Now we will see a lot of examples. It will be more clear to you. No worries. So these kind of concepts are very typical, which is not discussed in many lectures. But we will see everything that can be asked in future. So what do you think? What should be the output of the circuit? Here again you can see two standard circuits. You can again see two standard circuits. Okay, this is the last circuit only. Okay, this is the circuit that we have already seen till now. But now we will solve it by the method that I told you. So what I need to do, first I need to turn on D1. So how will I turn on D1? So I will write need to turn on D1. So when, what is V in? V in by default is Vm sin omega t. If I forget to write, you just need to consider Vm sin omega t only. So when V in is equals to minus Vm, D1 will turn on. D1 will turn on. Then what will happen? If it is turned on, when V in is equals to minus Vm, this is capacitor C, this is turned on, here minus Vm is applied. So this capacitor will be charged to minus Vm, right? That means in the opposite direction, it will be charged to Vm, like that. So it will be charged to Vm in this direction. In this direction, it will be charged to Vm. So Vc1 will be minus Vm. That is its steady state voltage. Now what is the scene in the circuit? The scene in the circuit is, since the diode turns on, it is charged in this direction. So I will write plus Vm like this. And this is V. This is D1. D1's work is done. D1's work is done. So now we are coming here at this point. V in plus Vm. Now you need to turn on D2. Need to turn on D2. D2 can turn on when V in is 0. D2 can turn on when Vin is 0, but we will turn it on at the maximum positive supply. So when Vin is equals to plus Vm, D2 is on. D2 is on. And if D2 is on, that when Vin is equals to plus Vm, that means when D2 is on, this capacitor C, here you are having what? 2 Vm. Here you are having 2 Vm. So now this capacitor C will be charged to 2 Vm. That's it. That's your final answer. Did you understand this point? So this method is very important. When you see a complex circuit, this method will be used and you will be able to solve the problem very, very quickly. Well and good. Let's move on to the next one. This one. Tell me the output first, because here you can see two standard circuit. What is this? What is this circuit? Negative clamper, right? This is negative clamper. Before writing this, let me copy this circuit because we will be solving it with two methods. Method 2 we will be using on the next page only. But first let's solve with method 1. Yeah. So here we can see two circuits. This is the first one, which is negative clamper. So what does negative clamper do? What will be the output of negative clamper? That would be V in minus Vm, right? V in minus Vm. And what is this? This circuit is negative peak detector, right? This is negative peak detector. So what is this voltage? This voltage I am calling V dash. So V dash is V in minus Vm. That is Vm sine omega t minus Vm. So what is the negative peak of this? Negative peak of this? 0? No. What is the minimum value of sine omega t? That is minus 1. So negative peak of this will be minus 2 Vm. You can draw this graph, right? Negative peak of this will be minus 2 Vm. Right? Minus 2 Vm, like that. This graph will go like that. Negative peak is minus 2 Vm. So your V naught steady state would be minus 2 Vm, right? And what about Vc1? Tell me what will be the value of Vc1? It will be plus Vm at steady state. It will be plus Vm. At steady state it will be plus Vm. Also, you know, here it is Vm, here it is V in, and here it is V in minus Vm. So what should be the value of Vc1? That should be plus Vm only. Or you can say that the capacitor will charge in this direction. When V in is equals to Vm, the diode will be on. When V in is equals to Vm, the diode will be on. So the capacitor will charge in this direction, that will be charged to plus Vm. Well and good. Now let's see the method 2. What is method 2? That I told you. First you need to turn on the diode, then you need to turn on the other diode. This is method 2. Let's call this one as D1, this one as D2. So need to turn on D1. So when Vin is equals to Vm, diode D1 turns on. So Vc1 would be equals to plus Vm. Well and good. Now what about this potential? V dash would become V in minus Vm. V in minus Vm. D2 will, now D2 can turn on when Vin is equals to 0. When Vin is equals to 0, D2 can turn on. But we will take the maximum negative supply. We will take the maximum negative supply. So when Vin is equals to 0, it can turn on, but we will take the maximum negative supply. When Vin is equals to minus Vm, diode D2 is on. So we are taking the maximum negative supply. That means this V dash would be minus 2 Vm. At that time, V dash would be minus 2 Vm. So this we don't need to write. Simply you can see that this is diode D2. This is capacitor C. This potential is minus 2 Vm and this is V out. So V out steady state would be minus 2 Vm and Vc1 would be plus Vm and this is equals to Vc2 only. Are you getting the method? Right? Tell me the answer of this question. Answer of this question. Take your time and tell me the correct answer. What is the V0 value? Plus 2 Vm, minus 2 Vm, Vm or 0? 0, right? Why it is 0? What is this? Peak detector. Sorry, not peak detector. Positive clamper. This is positive clamper. And what about this? This is negative peak detector. This is not positive peak detector. Positive peak detector arrow is in this direction. Here the arrow is in this direction. That means it is negative peak detector. This is negative peak detector. So let's call this potential as V dash. So what will be your V dash? Positive V dash is this is positive clamper, so V dash will be V in plus Vm. That means it would be Vm sin omega t plus Vm. Tell me what is the minimum value of this? Because this is negative peak detector, that means it will detect the minimum value. Positive peak detector detects the maximum value. What is the minimum value of this? What is the minimum value? Minimum value of this is 0 volt. So it will detect the negative peak. So that is 0 only. What is the graph? Graph looks something like this, right? It will detect the negative peak. So your V out will be V out steady state will be 0 volt. So people will think this is a standard circuit or anything 2 Vm minus 2 Vm, nothing like that. Output is 0 volt. Okay, this kind of circuit hasn't been asked in the gate yet, but they will be soon asked. Okay, so gate hasn't asked this kind of question, but they will soon ask it. So this is your steady state output. What about Vc1? What is the steady state value of Vc1? Steady state value of Vc1 is minus Vm. I'm not going to explain why it is minus Vm, because when will the diode turn on? Diode will turn on at Vin equals to minus Vm. So capacitor will charge in this direction. So Vc1 will be minus Vm. This is also steady state. Okay, do I need to solve this question with the second method? You guys will be able to understand, right? What we need to do? We need to turn on this diode first. So how we will turn on? When Vin is equals to minus Vm. If when Vin is equals to minus Vm, this will be charged to plus Vm in this direction. Now this potential will be Vin plus Vm. Now I need to turn on this diode. So at what value of Vin this diode will turn on? 0? No. At Vin equals to 0, this will not be on because this potential will be Vm. So Vin should be equals to minus Vm. When Vin is equals to minus Vm, this diode may turn on. When Vin is equals to minus Vm, what will be the potential here? 0 volt. Here also 0 volt is there because initially capacitor is not having any charge. So 0 volt, 0 volt. When there is 0 volt, we can consider diode to be on. So in this chapter, everywhere we are considering diode to be on when there is 2 zeros. So we can consider diode to be on. If the diode is on, what will happen? The 0 will go to the capacitor C. So V0 will have 0 voltage only. Got this point? Well and good. Do I need to solve it with the other method? You can solve it on your own, right? You can do it, right? Okay. I'm leaving it up to you. I have explained how it is. First, plus Vm, then V in plus Vm is there. So it will detect that it has to be on at the negative peak. So what is negative peak? That is minus Vm. So minus Vm plus Vm will be 0 only. So it will, capacitor will have only 0 voltage. So now let's move on to the next circuit, example 4. So what we need to do in this one? What do you think? What will be the answer? 2 Vm plus 2 Vm minus 2 Vm, Vm 3 Vm or 0? Again 0. Why so? What is this circuit? Negative clamper. And what is this? Positive peak detector. This is positive peak detector. That means it will detect the maximum value. Let's call this potential as V dash. What will be the value of V dash? Negative clamper it is, so V in minus Vm. That means V in minus Vm sin omega t. Oh, sorry. Vm sin omega t minus Vm. Vm sin omega t minus Vm. What is the maximum value of this function? 0. Maximum value is 0. Max value is 0. So what will be your output? V0 will be 0 volt. Well and good. And what about Vc1? For Vc1, the capacitor will charge in this direction. So Vc1 will be plus Vm. Until now, you guys must have remembered that when it is negative clamper, Vc1 is plus Vm. When it is positive clamper, Vc1 is minus Vm. You don't need to mug it up. रटा नहीं मारना इसका. कंसेप्ट पता है ना? सीधा ऐसे चार्ज होगा तो प्लस Vm आएगा, उल्टी डायरेक्शन में चार्ज होगा तो माइनस Vm आएगा. You don't need to mug it up because in the examination, what if they give this as Vc1? The answer will be changed. They can interchange the polarity, right? So in the examination, they can interchange the polarity, but here we are taking plus to minus, left to right. They can, in the examination, they can ask you from left to right. So Vc1 will be plus Vm. Well and good. Let's move on to the next one. Here, this is the example. Now, can you see any standard circuit here? Are your eyes able to detect any standard circuit? Vin is again same Vm sin omega t. Vin is Vm sin omega t only. So in the previous question, we saw that positive clamper, then positive peak detector, negative clamper, negative peak detector, positive clamper, negative peak detector. All those standard circuit we saw. Here, can you see? If I see more clearly, I can see it. Okay. Try visualizing. Try visualizing it. Look, what if I connect ground here? I assume ground here. Anywhere ground is not given, I can assume ground anywhere, right? This Vin, this complete Vin is going to this circuit, right? This complete Vin is going to this circuit, this one closed block. Are you agreeing with this point? What do I mean to say is, if this is ground, then this complete line is ground. This is also ground, right? If this is ground, this potential is Vin. One end of this diode, let's call this one as D1, this one as D2. We will solve it by multiple method. First, let's see this method. One end of the diode is D1 diode is connected to Vin. It is connected to Vin. Other end of Vin is connected to ground. Other end of Vin is connected to ground. This ground is going like this. One end of capacitor is connected to diode D1. One end of capacitor. Let's call this one as C1, this one as C2. One end of capacitor is connected to D1. Other end of capacitor is connected to ground. There you go. Tell me, what is this circuit? Positive peak detector, right? This is positive peak detector. So what will be the steady state value here? Plus Vm. That will be plus Vm. So what did I get to know? This is one circuit that is available, but I can't see it. So this will be plus Vm. There is one more circuit available. This is Vin. This is 0. This is Vin. Let's talk about diode D2. The negative end of diode D2. This is diode D2. The negative end of diode D2 is connected to plus Vin. one end of V in is connected to ground. Positive end of D2 is connected to this capacitor C2. Positive end of this is connected to capacitor C2, this plate, and the other end of capacitor C2 is connected to ground. Other end of capacitor C2 is connected to ground. This is ground here. This is ground. Are you agreeing to this point? Positive end of diode is connected to capacitor, the other end is connected to ground. What is this circuit? Negative peak detector. That means it will detect the negative peak value and the capacitor will charge in this direction. That means your output will be like this, plus minus Vm. Are you getting this point? The capacitor will charge in this direction. So your output will be plus minus Vm. From down to up it will be charged. So the ground is at plus, ground is at plus, ground is at plus, and the other end, the positive end, this end, that is at minus. It is charged like this. Here the negative end was at plus, this negative end was at plus, and the ground was at minus. So this negative end was at plus and this ground has what? Minus. What is the value of V0? 0. No, it is 2 Vm. Why so? What is the potential of this point? 0. What will be the potential of this point? Potential of this point will be plus Vm. What is the potential of this point? 0. What will be the potential of this point? Minus Vm, because this is 0 and it is plus minus Vm. So 0 minus Vm, this end would be minus Vm. What is V0? The voltage difference between these 2 points. What is V0? Voltage difference between these 2 points. That will be 2 Vm. That's it. Look, I could have made this problem very complex, but I tried to simplify it as much as I can. Right? I hope you have understood that concept. Vin is completely going to D1, that you can clearly see. So Vm would come here. Here it is tough to see. Although if you have good aptitude, what you would have seen, okay, here this diode will turn on and it will charge the diode. It will charge the capacitor in this direction because the diode will turn on from P to N. So it will charge the capacitor in this direction. So capacitor will charge to Vm like this. That's it. In 1 second only you could have write the value of C2 voltage. Then you could have seen this is 0, then this will be plus Vm. If this is 0, this will be minus Vm. What is V0? V0 is the voltage difference between these two nodes. So that would be plus 2 Vm. That's it. Right? So what will be V0? Coal aa gaya. Yeah, so V0 would be Vm minus of minus Vm. Vm minus of minus Vm. That would be equals to 2 Vm. So this was our method 1. This I would say method 1, where we could see the standard circuits. Let's check out the method 2. So for that I need to copy the circuit. Yeah, so now we will see method 2. So what is our method 2? Turn on the diode and see the voltage across the capacitor. Now I told you, you should turn on the diode which is nearest to the supply. Here both are near to the supply. D1 is also near and D2 is also near. So which one I should turn on? Anyone. Any diode you can turn on. So let's try with when Vin is plus Vm. So when Vin is plus Vm, what will happen? D2 will turn on? No, because here plus Vm, so D2 will not turn on. So what will turn on? D1 will turn on. D1 turns on. Turns on and D2 is off. I should not write turns on because it can turn on at 0 voltage only, but we will take maximum only. Plus Vm minus Vm, plus Vm minus Vm. We will take only the maximum voltage. So I should write D1 is on and D2 is off. So what will be the circuit? This will not come in action. These wires will not come in action. Even the C2 will be open-ended. So if D1 is on, this will be C1. This is V in, which is directly exposed to capacitor C1. This is directly exposed to capacitor C1 and V in is equals to Vm only. So I should write Vm only. Vm. And this is open-ended. So this wire is gone. There is no meaning of this wire. and C2 will be also open-ended. No charging will be there. This end is not grounded. This end is open-ended because this is off. So there is no meaning of that. So all are open-ended. So C2 is open-ended. So there is no meaning of C2 here. So this will be charged to plus Vm. This is the first cycle. Okay. In the next cycle, what will happen? Now this is the steady state value of capacitor C1 voltage. Now we need to think about D2. So when Vin is equals to minus Vm, what will happen? Here capacitor C1 is having Vm voltage. This is grounded and this is having Vm voltage. I should use different color of pen here. This is having Vm voltage. So this node will be Vm and this node is minus Vm. So this diode D1 will be off. What about this one? Here minus Vm is, so D2 will be turned on. So D1 is off and D2 is on. How will the circuit look like? D1 is off, the C1 will become open-ended now. So it will go something like this. It is going like this, and then there is this C2. Right? Well and good. Now Vin is equals to minus Vm. Vin is equals to minus Vm. This potential is minus Vm. And this is your Vin. So what you can write? This node is grounded. Here, this node is grounded. This potential is 0. What will be this potential? This potential is actually Vin. That is minus Vm. If this is 0, this potential is Vin. And Vin is equals to minus Vm. So this potential will be minus Vm. Now this same minus Vm will travel here. And this potential will also be minus Vm. Right? So the capacitor C2 is getting charged in this direction. Like this. Plus Vm. Because this potential is minus Vm and this is 0. Capacitor C2 is something like this. This is capacitor C2. This end is at 0 voltage and this end is at minus Vm. So what will be the potential across the capacitor? It will be plus Vm like this. Are you getting this point? Or you can see that it will be charged in this direction only. D2 will get on in this direction, so it will be charged in this direction. So if it is getting charged in this direction, that means positive will come here and negative will come here. Right? So C2 will have plus Vm like that. This is the potential of C2. So at steady state we can draw C1 and C2 potential. So only C1 and C2 potential I will be drawing now. This is C1 which was having Vm potential and this is C2 which was having Vm potential, and this we considered as ground. Right? This is our V node. What will be our V node? I have already explained. V node will be 2Vm. Well and good. V node is 2Vm. Understood? So that way also we can solve. First turn on diode D1, then turn on diode D2. Well and good. Let's move on to the next problem. Here we are going to study voltage tripler, quadrupler, and immense a lot of circuit we will see. This circuit, then this circuit, then this circuit. Very complex kind of circuit we will see, these circuits. Okay. So you don't need to worry about these circuits. You will be able to solve by that one method that I told you. Turn on the diode, turn off the diode. Here, are you able to see any standard circuit now? No. Now we can't see any standard circuit, nothing like that. Now we have to apply our aptitude. So that one method that you need to turn on the diode. Okay. So let's consider this as diode D1, this as D2, this as D3, and this as D4. So when D1 will turn on, Vi is equals to Vm. So our first task is to turn on diode D1. So let's call this one as C1, C2, C3 and C4. Vin is equals to Vm. D1 turns on, D1 turns on. So what will happen? C1 will charge. Not D1 turns on, I should write D1 is on. D1 is on. So C1 charges to Vm. In what direction? It will charge in this direction because D1 turns on, so it will charge in this direction. So if I am calling this as Vc1, this as Vc1, so what will be your Vc1? It will charge in this direction, so Vc1 will be plus Vm. Vc1 will be plus Vm. So this is charged to plus Vn. Let's talk about other diodes now. So this is Vin, so it will be Vin minus Vm, right? This potential will be Vin minus Vm now. We can call this as ground, right? This as ground. So this will be ground 0 only. Is there any initial charge on capacitor C2? No. There is no initial charge on capacitor C2, so this will be also 0. Here you are having Vin minus Vm. Is there any initial charge on capacitor C3? No. Here also you are having Vin minus Vm. Any initial charge on capacitor C2, C4? No. So here you are having also 0. So across D2 what you are having? Across D1 what you are having? Vin minus Vm. Across D2 what you are having? Vin minus Vm. Across D3 what you are having? Vin minus Vm. Across D4 what you are having? Vin minus Vm. But the direction are different. Are you getting this point? What is the scene now? I can draw it. There are 4 diodes. D1, D2 in opposite direction, then D3, then D4. All are 0. Lower end are all 0. This potential is Vin minus Vm. Vin minus Vm. Vin minus Vm. Vin minus Vm. Right? Now what will happen? Vn equals to Vm has come. Now the turn is of for minus Vm. For Vn equals to plus Vm we have checked. Now we will check for Vn equals to minus Vm. Now yeah, one more doubt people can have, sir, that at Vn equals to plus Vm even D3 will turn on. Yeah, D3 will also turn on. This I forgot to tell. When Vn is equals to plus Vm, what will happen? D3 will also turn on. Are you agreeing to this point? Yeah, D3 will also turn on. But if D3 and D1 will turn on and D1 is on, D3 is on. When Vn is equals to plus Vm, D1 will be on, D3 will be on, this D2 will be off and D4 will also be off, right? Because when Vn is equals to plus Vm here and plus Vm here, D2 and D4 will be off. So D2 and D4 will be off. D2 and D4 is off. So what will be the scene? The scene will be something like that. This is your Vn. Now here there is capacitor C2. There is this capacitor C3. D2 is off, it will not come in action. Then D3 is on. And then D4 is off. So there is no use of it. Right? So this is open-ended. Now I am saying that this C1 is charged to plus Vm. That's all right. But C2 and C3 are closed in 0 potential. Both are closed in 0 potential. If I say this is my circuit, both capacitors are having no voltage. Both capacitors are having no voltage. So they will be at 0 voltage only, always. So both are closed in 0 potential. What is happening? This Vi is completely exposed to C1. C2 and C3 are not even coming in action. Are you getting this point? Okay, so there is no meaning of that. That's why I forgot to write. I should have written like this, that even D3 turns on and D1 D3 turns on, D2 D4 are off. Now what is the scene? That now Vn is equals to minus Vm. Vn is equals to minus Vm. So this I can write as second case, when Vn is equals to minus Vm. This was our D1, D2, D3 and D4. When Vn is equals to minus Vm, D1 and D3 are off. You can clearly see here, if it is minus Vm, D1 and D3 are off. What will happen? When Vn is equals to minus Vm, this will be minus 2 Vm. That means D2 and D4 are on. So what will be the scene now? Let's remove it off, because we have already drawn it. 0, 0 here I can keep, other I can remove it off. Okay, so this potential is minus Vm. So what will happen? What will be the potential here? Minus 2 Vm. What will be the potential here? Minus 2 Vm, minus 2 Vm, like that. Okay, and all these potential are 0 only. Now which two transistors are turning on? D2 and D4, and D1 D3 are off. D2 and D4 are turning on. So let's check what is the scene. D2 is turning on and D4 is turning on. This is the method how we are going to solve. Since I am explaining it, it will take time. But once you are comfortable with that, it will not take that much of time. D2 and D4 are turning on, so C3 and C4 will come in action. C3 and C4 will come in action, no? D2 and D4 are turning on. D2 is turning on and D1 is off. So even from here also it will come in action. What I will do, I will just simply copy this circuit. Yeah, so this would be an easier way. So D1 is off, so I can remove it off. D2 is on, D3 is off, I can remove it off. And D2 is on and D4 is on. So I will simply replace it with a straight line. Now, will there be any charge on C3 and C4? No, again, because they are pegged in zero potential. So there will be no charge on C3 and C4. Now what will happen? See this loop. You just need to see this loop. What is the potential here? 0 volt. The potential here, that was 0. This is 0. 0 volt. Minus Vm. This is minus Vm. Minus of Vm. That will be minus 2 Vm. Minus Vm. Minus of Vm. That would be minus 2 Vm. So here minus 2 Vm is coming. Right? That means this capacitor C2 is charged to 2 Vm voltage in this direction. Did you understand this point? Minus Vm, minus Vm, minus 2 Vm. Here 0, here minus 2 Vm. Did you understand it? Well and good. So this capacitor is charged to 2 Vm. Also, if you are confused with the direction, you can see D2 will charge the capacitor in this direction. So it is charging the capacitor in this direction by 2 Vm, not by Vm, by 2 Vm. Well and good. Now again what will happen? Vm will come. So again Vm will come and I will have to copy these 4 again. Array. Now all these potential are changing now. Why these are changing? Because circuit is different now. Let's copy this circuit again. I will copy it. Yeah, so what did you see here? This capacitor C2 was charged to plus 2 Vm. this capacitor C2 was charged to plus 2 pm. Now this potential is 0, that is fine, but now this potential has become minus 2 pm, and this potential will be V in minus Vm. This potential will be V in minus Vm, and lower end of D1 is connected to 0. What about D2? V in minus Vm, lower end is connected to minus 2 Vm. C3 is not charged, so V in minus Vm will be here. V in minus Vm will be here. What about the lower end? That will be minus 2 Vm. What about D4? This C4 is also not charged, so minus 2 Vm will be going here, and the upper end will be this complete V in minus Vm will be traveling here, and this minus 2 Vm is traveling here, like that. V in minus Vm. Good enough? Yeah, so now this is the scene. Now what will happen? V in equals to plus Vm will come in action. This I can remove. V in equals to plus Vm will come in action. If V in is equals to plus Vm, what will be the potential here? 0. Plus Vm minus Vm, 0. 0 volt. This is 0, this is minus 2 Vm. This is 0, 0 will also travel here. See, 0 is also traveling here. So this is 0, and this 0 will also travel here. This will be minus 2 Vm, and this minus 2 Vm will also travel here, and this 0 will also travel here. So which diode will turn on? Tell me. When there is 0 volt, diode turns on. I told you. So D1 will turn on, which also this one will also turn on, right? D3 will also turn on. 0 minus 2 Vm. Or from here you can see when Vn is equals to Vm, this will be 0, this will be minus 2 Vm. So 0 minus 2 Vm, D3 will turn on. What about this D2? Here 0, here minus 2 Vm, D2 is off. D2 is off. What about D4? Here 0, here minus 2 Vm, D4 is off. So now when Vn is equals to plus Vm, what is happening? D1 and D3 are on, D4 and D2 are off, right? So which are off? They will be gone. These will be gone. And what about D3 and D4? They will just be shorted. You should be doing this in your rough notebook, then only you will be able to understand. Otherwise, you will just see that he is not teaching good. Okay, you will just make an excuse that he is not teaching good. But concepts are complex, and like 10 out of 11 teachers will tell you that directly remember it. Okay, Vm, then this will be charged to 2 Vm, then this will be charged to 2 Vm, then this also will charge to 2 Vm. But here I am giving you the concept because new question may come up in front of you. This is a very standard circuit. In the end, I will tell you how to write the final answer of this in just 10 seconds. That I will tell you. But what if new question comes up? So you should be able to solve those problems. And if you have good enough practice, you will be able to solve very quickly. Here I am explaining, that's why it is taking time. Right? So forget about this, forget about this. Now we just have to write the potential. Just let it be, let it be, let it be. Okay. What will be the potential of C3 now? These two are connected in what? In a loop. So whatever the potential C2 is having, the same potential will be going towards C3. Two capacitors are in parallel. Both of them will have the same value, right? 2 Vm will be given to the C3 as well. That's it. So C3 will also have 2 Vm. Now this we have seen, right? Now C3 is also having 2 Vm. So now what will be our next cycle? The next cycle will be the last one. But before that, we have to copy these 4 circuits. So let's copy this circuit. Yeah, so these are the circuits. This is C1 is charged to Vm, C2 is charged to 2 Vm, and C3 is charged to 2 Vm. Till now we have seen this circuit, right? So this potential will be now V in minus Vm, and this potential will be 0. So D1 is having V in minus Vm and 0. What about D2? This potential is 0, this potential is minus 2 Vm, and this potential is V in plus Vm only. So D2 is having, sorry, V in minus Vm and minus 2 Vm. This is what D2 is having. What about D3? This is V in minus Vm. This will be V in minus 3 Vm now, right? D3 is having V in minus 3 Vm. Are you agreeing to this point? V in minus 3 Vm. So this potential is V in minus 3 Vm and this potential is minus 2 Vm. What about D4? C4 is having no voltage. So this minus 2 Vm will be going here as well. Minus 2 Vm will be going here as well. And this V in minus 3 Vm will be going here. V in minus 3 Vm will be going here. Right? This is the scene now. Well and good. Let's say move it off. Just to write the potential, I did that. Right? Yeah. Okay. Now what is happening? Vm equals to minus Vm is coming. First we started with Vm, then minus Vm, then plus Vm, then again minus Vm. So Vin is equals to minus Vm. Which one will turn on? D1 will turn on? No. When Vin is equals to minus Vm, this will be minus 2 Vm. D1 is off. What about D3? This is minus Vm, so this will be minus 4 Vm. Here minus 4 Vm, here minus 2 Vm. P is having more negative. So D1, D3 are off. What about D2? This is minus Vm. So minus 2 Vm and minus 2 Vm. Both potential are equal. That means it will turn on. Vn is equals to minus Vm. So here it will be minus 2 Vm and this also is minus 2 Vm. Both potential are equal. D2 will turn on. What about D4? This is minus Vm. That means this will be minus 4 Vm and this will be minus 2 Vm. Which is having more negative potential? N side is having more negative potential. This is more negative. So D4 will turn on. D1, D4 are on. So how will the circuit look like? When D2 and D4 are on. D2 and D4 are on. These are off, they will be gone. They are off, they will be gone. D2 and D4 are on. If they are off on, that means they will be shorted. Now in one pack, what is coming? C3 and C4. So whatever the potential C3 is having, the same potential will be given to C4. So C4 will also be charged to 2 Vm. That is the steady state. C1 is charged to Vm, 2 Vm, 2 Vm, 2 Vm. That's it. So now I will copy the final circuit and will write the potential of each and every capacitor. Okay. So look, one thing we already know that here Vm would come and here 2 Vm, 2 Vm, 2 Vm. This is what we can remember for a standard circuit. You can remember this much of thing, that first capacitor will be charged to Vm, rest will be charged to 2 Vm. Now you don't know the direction. You know one thing, that first will be till Vm, rest will be till 2 Vm. This you can remember. Very easy thing. Vm, rest will be 2 Vm. Now you don't know the direction. How you will know the direction? By diode. Very easy. This D1 will turn on, this will drive in this direction. That means C1 will be charged in this direction. You can see that this D1 will turn on, it will charge in this direction. Then what will happen? D2 will turn on, it will charge in this direction. Then what will happen? D3 will turn on, it will charge in this direction. And D4 will turn on and it will charge in this direction. So direction is going in this manner, like this, like this. Are you getting this point? So plus minus, like this, going plus minus 2 Vm, then plus minus 2 Vm, then plus minus 2 Vm. By the arrow of diode, you can get to know the direction of current. So if the current is flowing like this, Vm, 2 Vm, 2 Vm, 2 Vm, like that. So if you see the standard circuit and in the examination, they are asking you what will be this potential. Tell me what will be Vc3. So will you be solving it in the examination? No. What you will do in the examination? Okay, you will directly see This is the standard circuit, I know, but I remember one thing, that first will be charged to Vm, rest will be charged to 2Vm. Now I just need to see the direction. How I will see the direction? Like this. Vm, 2Vm, 2Vm, 2Vm. So this is what I will be doing in the examination. Well and good. No worries. Now, how it is voltage doubler or quadrupler? So if you are collecting your output here, one pin is here, the other pin is here, and I am saying that this is my output. I am saying that this is my output. This is my output. So what will be my output? Vm plus 2Vm, 3Vm. And if I am collecting my output here, I will say that this is my one point, this is my other point, and this is my output. So what will be my output? 4Vm. So here it is acting as voltage quadrupler, here it is acting as voltage tripler. Are you getting this point? If I had said that this is my output, what will be my output? If I said that here I am taking the positive node and here I am taking the negative node. I have a voltmeter. This I am connecting as positive node. This I am connecting as negative node. What will be my output? Minus 2Vm, right? Because this is the positive and this is the negative. So output will be minus 4Vm. Well and good. But till for now we are collecting like this. 4Vm and 3Vm. Are you able to understand the complete concept? Now I will revise this complete concept very quickly. Now if you see the question in the examination, I don't know anything, what I would have done? Okay, first I would charge the capacitor C1 till Vm. Okay, then what is happening? First Vm would come, now minus Vm would come. If minus Vm is coming, that means minus 2Vm would come here. So that means this D2 will turn on and D4 will also turn on. So if D2 and D4 are turning on, that means C1 and C2 will be coming in action, and C3 and C4 will be coming in action. But since they are in a pack, so C3 and C4 will not get charged. This will be the condition, that C3 and C4 will not get charged. Now C2 will get charged to minus 2Vm. In the next cycle, plus Vm would come. So by that I will get to know that my D1 and D3 are turning on, rest are off. Now the same potential that C2 is having, the same potential will be given to the C3. So that will be also 2Vm. Then in the next cycle, what will happen? D2 and D4 will turn on and D1 and D3 will be off. So whatever the potential C3 is having, the same potential will be given to C4. That's it. Or if this is a standard circuit, I know one thing, first will be charged to Vm, rest will be charged to 2Vm. By the direction, I can simply write the potential. So in 30 seconds, I will be able to solve the problem in the examination. Now, what if the problem comes like this? Will you be able to solve? See the direction of diode. Yeah, no worries. How I will solve? It will charge in this direction now. This is the standard circuit only. But it will charge in this direction. Like this. It will charge like this. Well and good. One thing I know, this will be charged to Vm only and rest will be charged to 2Vm. Direction is this, 2Vm, 2Vm, 2Vm. Now your task is to solve this problem by the previous method that I told you, that you can do on your own. What you will do? First, your target is to turn on this diode D1. So what potential should be there? Minus Vm. So first minus Vm would come. So minus Vm comes, the capacitor is charged to minus Vm. Then what will happen? Plus Vm would come. So if plus Vms come, D2 and D4 will come in action. D2 and D4 will be turned on and D1 and D3 will be turned off. So because of that, this will be plus Vm and this will be plus Vm. So 2Vm will be here and this is 0. So this capacitor C will be charged to 2Vm. In the next cycle, what will happen? Minus Vm would come. So minus Vm is coming. So what will happen? D1 and D3 turns on. D2 and D4 are off. And if D1 and D3 turns on, that means this 2Vm will be given to this 2Vm will be given to this capacitor. So it is charged to 2Vm in this direction. In the next cycle, what will happen? Plus Vm would come. So D2 and D4 will turn on, rest will be off. So this 2 Vm will be given to this capacitor. So like this, it will be given to this capacitor. So it will be charged to plus 2 Vm. Understood? You can write it on your paper. You can more understand it more in this 30 or 40 seconds only. I have made you understand everything. Right? समझ में आ गया सब कुछ? कैसे ऑन हुआ, Vm तक चार्ज हुआ, देन 2 Vm आया, फिर यहाँ पे 2 Vm कैसे आया, ये सेम कॉपी हो गए, ये वाला 2 Vm यहाँ पे आ गया. So what is the thing now? How will you get the voltage quadrupler and voltage doubler? You can also get voltage doubler from here, right? How will you get voltage doubler? Just this. This is my output. This is my voltage doubler. That's it. If I only want peak value, this is my output. This is my peak detector. You can get Vm as well. You can get 2 Vm. You can get 3 Vm. You can get 4 Vm. Well and good. So if I am collecting my output like this, tell me what will be my output. If I am collecting my output like this, what will be the output? Plus Vm. Sorry, plus 4 Vm or minus 4 Vm. Minus 4 Vm. Because from here to here, let's assume this is ground. This is 0, this will be 2 Vm, this will be 4 Vm. So this potential is 4 Vm and this potential is 0. But this node is 0 for me and this node is positive for me and this node is negative for me. So 0 minus 4 Vm is minus 4 Vm. 0 minus 4 Vm. That means it will be minus 4 Vm. Basic network analysis it is. Simple network analysis, first chapter of network analysis. Right? 0 plus 2 Vm plus 2 Vm. So 0 here and 4 Vm here. So what will be the potential? Minus 4 Vm. And if I am collecting my output like this, so what will be my voltage? That would be plus 4 Vm, because this potential is plus 4 Vm. So here I am connecting the positive node and here I am connecting the 0 node. So it will be plus 4 Vm. Right? On the upper side, it will be tough to write, yeah, because this more example is coming here. This I can replace somewhere else. So if I am collecting my output like this, this will be 3 Vm. But how? If I am collecting like this, what will be this? This will be minus 3 Vm. Right? Because whatever potential it is, you can assume it is x potential. So this is x plus Vm, x plus 3 Vm. So this is x plus 3 Vm and this potential is x. So if I need to write my potential, this is my positive. So x minus this is negative, x minus x plus 3 Vm. So my potential would be minus 3 Vm. So here my potential would be minus 3 Vm. So where you are taking the positive node, that matters a lot. And if I had taken the opposite, it would be plus 3 Vm. That I don't need to write. So understood this concept? Like this arrow and everything, you understood it, right? Now we will see one more circuit, this one. Then there are other circuits as well. Yeah, this one is also there. Then more circuits are there. Oh, one more is there. 3 circuits are there. So I guess we should take it to the next lecture. I will add up more circuits. Okay. Try to solve this circuit before watching the next lecture. You can try to solve this circuit. How it will look. What will be the output here? What will be the potential of this capacitor? What will be the potential of this capacitor? You can try doing it. The simple method, you need to turn on one diode. First Vm would come or minus Vm would come, because this diode, if I want to turn on, so I would first take minus Vm. So if minus Vm is coming, then what will happen? You can try it on your own, or you can see 2 circuits here. Again, I can see 2 circuits here. This Vin is exposed to this circuit. Then this Vin is exposed to this circuit as well. What kind of circuit are those? Can you see? This is, first it is positive clamper, then peak detector. Then this one is negative clamper and then peak detector. So what will be the potential here? 2 vm 2 vm, output will be 4 vm. So like that you can try solving it. In the next lecture we will solve it more completely. This also you can try. Can you see the circuits here? Again I can see this is what? Positive peak detector, positive clamper, then peak detector, and this is what? Negative peak detector. So this is negative peak detector. Again you can see what will be the output? 3 vm. Also you can try solving this circuit as well. Understood? Well and good. So try solving this these three circuits, and I will add up more circuits. So in the next lecture we will see. Also comment down how did you find this lecture? Okay, because this was very intuitive, and you wouldn't find these kind of lectures in YouTube, right? So yeah, you can comment down. Okay, thank you. Let's meet in the next lecture.